Welcome to Study Loop.
Let's evaluate the definite integral from 0 to 1. So the denominator is already factored. Let's go ahead and do a partial fraction decomposition. So we have a over x plus 1. But then since this is a repeated factor, we have another constant b over x plus 1 squared. Then we have another linear factor over here that's different. So that's c over x plus 2. And now let's go ahead and multiply by the denominator. X plus 1 squared, x plus 2. So both sides of this equation. So on the left-hand side, we're just left with the numerator. But on the right-hand side, we have a x plus 1 times x plus 2 plus b times x plus 2 plus c times x plus 1 squared. Now let's just go ahead and expand the right-hand side. So next to a, we have x squared plus 3x plus 2 plus b x plus 2 and then plus c and then x squared plus 2x plus 1. And now let's go ahead and factor out x squared. That leaves us with a plus c. Then let's pull on x. Left over with 3a plus b plus 2c. And then finally for the constant term, we have 2a plus 2b and then plus c. So now we compare the coefficients on each side. On the left-hand side, in front of the x squared, we have a 1. Whereas on the right-hand side, we have a plus c. So we have a plus c is 1. Similarly, the coefficient on the left-hand side in front of the x is 1. The coefficient on the right-hand side is 3a plus b minus 2c. So those are equal. And finally, the constant term on the left is 1. The constant term on the right is 2a plus 2b plus c. So those have to be equal. We'll have a 3x3 system and the coefficients a, b, and c, which we can solve. Let's go to the next page to do this. We have a plus c equals 1. 3a plus b plus 2c equals 1. And then we also have 2a plus 2b plus c equals 1. Many ways to solve this 3x3 system. For example, we could take the first equation, solve for c, and then we could plug this value of c into the other two equations. So plugging this c value into this equation up here, we have 3a plus b. Now 2c becomes 2 minus 2a. And then we could simplify that to become a plus b equals minus 1. Similarly, plug in c into the final equation. You have 2a plus 2b plus c, which we write as 1 minus a. That equals 1. Now simplify this. A plus 2b equals 0. So now we have a 2x2 system that we can solve in a and b. From this last equation here, we could solve a. And then we could plug this a value into the other equation. We'll have negative 2b plus b equals minus 1, which we can solve as b equals 1. By this equation up here, a is negative 2 times 1. And then by the first equation over here, we have c equals 1 minus a, so c equals 3. Now that we have the values for a, b, and c, we could plug those into our partial fraction decomposition on page 1. So let's go on to page 3 to write this out. We now have the integral from 0 to 1. Then we have our a over x plus 1. B, which was 1, over x plus 1 squared. And then c was 3. So we had 3 over x plus 2. And this is a much easier expression to integrate than the problem the way that it was written. And if you don't like these plus 1s and plus 2s on the x, you can go ahead and do a u sub. For this first one, you could try u equals x plus 1. For the last one, you can try u equals x plus 2. And even for this one, you can try u equals x plus 1 as well. So when we go ahead and integrate these, for the first one, we have negative 2 natural log absolute value x plus 1. Then using the power rule, we have negative 1 over x plus 1. And then plus 3 natural log absolute value x plus 2. And our endpoints, 0 and 1 still. Now we just go ahead and plug in 1 and 0 for x. So this is what we get when we plug in 1. Now go ahead and plug in 0. And that's what we have. And now we simplify as much as we can. We have a natural log of 1. That's a 0. And then we'll combine like terms here. So we have negative 2 natural log 2, and then minus 3 natural log 2. That becomes negative 5 natural log 2. And then we have a negative 1/2, but then we have a plus 1, so that's a plus 1/2. And then we have a 3 ln 3 left over. And now we could just go ahead and simplify this. I mean, this is a numerical answer, so we could stop here, but if you have to simplify, we can write this as ln 3 to the 3rd power. Then I have, let me write this over here as minus ln 2 to the 5th power, so that's 32, plus 1/2. So I just use the log property. I'm using the log property that a natural log b is ln to the a power. And finally, we have a log minus a log, so we can write this as a log of a fraction using another log property. Plus 1/2, and there's our final answer.